Welcome to the ARM School program. This video is taken from our teacher training program on edX.org called Teaching with Physical Computing. Whether you're new to teaching computing or a specialist, this program will set you up on a path to becoming an expert in delivering technology-enabled project-based learning in the classroom. In this module, we explore the resources and tools available to teachers and how the ARM School program seeks to mitigate the challenges and support colleagues in introducing an exciting and effective pedagogical change using project-based learning.
In this module, we will look at what tools you can use or make to help you build up the ultimate PBL toolkit. Nothing is too hard if you deal with just a little bit at a time. Decomposition is the idea of taking a difficult problem and breaking it down into just the bits you can deal with. How about using a Word file? Bullet point the problems you need to solve, then go back and indent the bullet points under each one, splitting it down into simpler and simpler tasks. Always look for the opportunities to break the proposed solutions down into inputs, processes, and outputs, whether it's a program, a robot, or a learning tool. An IPO table should be in your arsenal of resources for the learners, but you also need to decide whether you will let them spend the time trying to figure out the IPOs themselves, spend a bit less time doing it as a group, or save the time and lose some potential creativity by doing it for them. Every learner has probably been told at some point to learn from their mistakes. Planning a PBL project is no different. There are a wealth of methodologies you could put into designing your project, from the latest of Agile to the most traditional of waterfall methods. However, the simple cycle of plan it, do it, review it, and then do it all again is the most important part. Computational thinking really should be at the heart of everything we do. Are you building in the skills to abstract useful information from problem briefs? Are you teaching the learners how to decompose a problem? Are there opportunities, and if needed, prompts, to similar problems that they can identify patterns in? Can they set out a solution in a reproducible manner? That is, can they produce an algorithm? Creating ideas is not something that can be taught, but the tools you put in the learners' hands and minds can help them learn how to ideate. Have you built in enough opportunities for them to practice? Do they know what to do and what you want from them? Do you have the confidence to go wild? Learners are taught to get things right and only right, and sometimes that's a hard habit to break. It can be a good idea to have some ideas to prompt them with, or kickstart the creative flow. Successful group work doesn't just happen. It has to be designed and finely crafted. What kind of groups do you want? Mixed ability? Differentiated? Big or small? Do you have a rationale, or are you winging it because it feels right? How are you going to assign learners to the groups? Alphabetically? By height? By friendship groups? Or something a bit more educationally valid? Groups will automatically produce certain roles. Do you know what to look for? Do you have a plan to nudge certain people into certain roles? We discussed elsewhere that marking purely on group work is not beneficial, but nothing for group work can be counterproductive. Have you got a plan for what the collaboration is worth? Every learner needs some sort of support, but do you know what they need? Have you actually tried asking them, or are you planning on just hoping that what you produce is the right support? Are you blindly going through creating video tutorials for everything and A3 copies of each handout? Or have you done an analysis of what parts of the project are most likely to need support, and saved your precious planning time when it's less likely to be needed? Keeping it super simple is exactly that, simple. Don't set your learners up to fail. Make sure the end goal is attainable by everyone. If there's a chance that students are going to overcomplicate things, put a boundary around the project that stops things getting out of hand. Make sure they have the resources they need, whether that is physical resources, training, or just knowing who to ask for help. Ensure their success criteria are SMART. And most importantly, make sure they know all of this, that you have communicated the path to success to them. Lateral thinking doesn't necessarily come naturally to learners. They may need teaching how to do it. Do they even know what it means? Have you told them what you're looking for? And do they have the confidence to do it? If you're going to use a tool, such as De Bono's 6 thinking hats, it's really important to start off by using them as a teaching tool. If learners have to get their heads around thinking how to think, and they actually have to sum up problem solutions all in one go, they may fail to do so. So learn how to think, then start thinking. Your time is one of the most precious commodities, so work smart. Work with others if you can, and only plan what is needed, especially if you can find it elsewhere instead. Plan what needs planning and stick to your plan. Help your learners think like engineers, and build in opportunities to develop the skill set. Engineers, like computer scientists, like building things. Most educators see teaching as a vocation. By linking to life skills such as teamworking and communication, not only will the learners engage with learning better, they stand a better chance of having a successful working and personal life.
To learn more, head over to edX.org and search for project-based learning and enroll for free.